Hello students, today we will be going over 11.2, using regression models to predict outcomes. Our objective, I can create scatter plots and describe associations and use regression models to predict outcomes. We have a couple of vocabulary words here. Regression model or line of best fit is a line that best expresses the relationship between the points. Lines of best fit can be linear and exponential. Next, it says using regression models to predict events in context. Jack invested money in the stock market. The graph shows the value of Jack's investment over time. The model is what? Is it linear or exponential? So if it's linear, it's going to make a straight line. If it's curved at all, it's going to have to be exponential. So we're going to say it's curving up, so we say it's exponential. According to the graph of the model, how long did it take the investment to be worth $4,700? Okay, we're going to go ahead and look at the graph here a little bit closer right here. So we want to go to $4,500 or $4,700 and go over and say how long was that? $4,700, just above that. Looks like it's about 12 years. Okay, so we put 12 years. Next, the equation for the model is y equals 2920 times parentheses 1.04 to the x. Using the equation of the model, how much will the investment be worth in 20 years? Okay, so we use this equation right here, and we say our x is going to be 20. Okay, so we want to figure out y equals, and you have to think, is 20 going to be our y or our x value? Okay, so since down here is years, it's going to be our x value. So we say y equals 2920 times 1.04 raised to the power of x, which is 20 years. We're going to substitute that in for x. Now, we must do exponents here before multiplication. So do not go to your calculator and multiply 2920 times 1.04 and raise that to the power of 20. You will not get the correct answer. So again, you have your handy dandy calculator right here. You want to put 1.04 in first. Now to raise it to a power, we use this y to the x button. So we go y to the x 20. Now we must put equals. So that'll give us a big old long ugly decimal. And that's okay. We're going to take that and leave it in there and just multiply it by 2920. So we take that, we go times 2920. Then whatever we get, we have to ask ourselves, does that make sense? And that's what we have. $6,398 and maybe 8 cents, because we're going to round up. And we want it to the nearest cents. Okay? So 6398.08. So we say how much is going to be, it is going to be worth $6,398.08. And you can write, and I think we could just leave it at, and we don't necessarily need to write a sentence. So there you go. All right, we're going to go on to number 2. Hopefully you can see okay that at the bottom. Okay, the number of marriage licenses issued by a country can be modeled by this equation. X is the year, Y is the number of licenses. Number, that's the number sign, not hashtag in this case. And it was number sign before, long before it was hashtag. This model is it linear or exponential? Well, we don't have a graph, so let's just look at our equation here. Now, is there any exponents? No, there's not. So we know the model is linear. So according to the model, how many licenses were issued in 2006? Round to the nearest whole. So X is the year, so we want to put in 2006 for X in our equation. So we have negative 3404 times 2006 plus 6,952,400. Okay, aren't you glad we have a calculator so we don't have to do this by hand? Okay, I'm going to put 3404, and again, to make it negative, we use the plus minus down here, and I make sure it shows negative 3404, and then I'm going to go times 2006. And then I'm going to add 695, this number right here, 2400. So it's 123,976. Okay. So y equals, and I'm going to double check one more time, 123,976 licenses. Oh, you know what? Up here it says 0.4x. There was a 0.4x, so I should redo that, and this should have a 0.4 in it, and that might make this a little bit lower. Why don't we just have you cross off the 0.4, and then it'll be correct. Okay, so cross out the 0.4. Licenses doesn't have the S right there. There we go. Okay, so delete the 0.4 in both equations and you should be good to go. I somehow didn't see that, and we're just going to move on. Okay. Okay, number 3. The population of a city is modeled by y equals 9360 times 1.1 raised to the x power. X equals the number of years, y is the population. The model is linear or exponential. Well, I'd look at this and I say, is there any exponents? Yes, there is. So it's an exponential equation, and it's an exponential model. Now, according to the model, what is the population after 12 years? So again, X is the number of years. So we're going to go 9360 times 1.1 raised to the power of 12. So handy dandy calculator. Make sure we do exponents first and then multiplication. So we go 1.1 y to the x 12 equals. And that doesn't matter if it's a big old long decimal. I'm just going to multiply it by 9360. So I go times 9360. And it says round to the nearest person. So I have 290 or 29,000 376. It's 75.68. We're going to round, so it's 29,376 people. Okay, you can get the rest of this, students. You rock.